Hello everyone. Thank you for considering using SCIP for your CMV interpretation needs. In this video, I will demonstrate how to set up and use the SCIP backend processing pipeline. Before I start, I would like to briefly show you the software architecture of SCIP. The center of SCIP is this visualization interface shown in green here that facilitates clinical interpretation of copy number variants. The data displayed in this visualization interface are generated by the SCIP backend shown in orange and purple here. The backend is also known as the Variant Filtration and Prioritization modules. In this video, I will demonstrate how to start from the scratch, set up this backend, and run SCIP for your own samples. To start, let's open the supplementary material of the SCIP manuscript and go to supplementary text 2. Supplementary text 1 and 2 will be updated as necessary on the GitHub SCIP webpage. The first thing we need to do is to fulfill the prerequisites. So we need to have a Unix-based operating system. This demo will be run on our high-performance computing cluster, which is based on CentOS 7. And we also need to have the following software installed, and you can obtain them from the corresponding official websites. Moving on to the first step. The first step is to download the required annotation file at the Google Drive links, depending on you are using HG19 or HG38. Then place it in a folder that you intend to install the SCIP backend modules. So let me pull this up. This is our high-performance computing cluster, and we already have the SCIP HG19 annotation file placed here. So we're done with step 1 and moving on to step 2. At the command line, copy the following code block depending on the genome build and press the Enter or Return key on your keyboard to execute. So we copy the HG19 version, we place it here, and we execute it. And it's done. The SCIP filtration and prioritization modules will be installed in a new folder called SCIP backend, which is exactly what it had just done. And we're done with step 2. Moving on to step 3. Step 3 is to obtain the OMIM gmap2.txt file from the official OMIM website. Because of licensing restrictions, we cannot provide this file directly to you, so you will need to go to the OMIM website, register, and it will provide a download link for you. We have already downloaded this file just here. And per instruction, we need to place the file in the HG19 file folder. So let's use the mv command to move the gmap2.txt to the HG19 files folder. And it's done. Step 4 and 5 basically focus on the backend configuration file. The name of the file is called pipeline.config.txt for HG19 or pipeline.config hg38.txt for HG38. There are just two things that we need to modify here. The first thing is this alignment path entry. Before we do that, let me show you what does this pipeline config file look like. So there are quite a few entries here, but we just need to edit a few. So the first thing we need to edit is this alignment path entry. So we use the Vim editor to edit this file. And we paste the actual path here. So you can see it is now showing the actual path. So one thing that we do need to pay attention is that for each given sample within this alignment path, each sample must have its own subdirectory. So for example, if we list for this given sample, we can see that the CRAN file and the index file for this given sample 033001 is within its own subdirectory. So this is one thing that you will need to make sure when you place and organize your alignment files. It is also explained here that each sample must have its own subdirectory. For example, for alignment file for sample 001 should be placed at alignment path folder sample 001 and then sample 001.bam. Moving on to step 5. Step 5 is specifying this ref.bam entry. For SCIP, we need to specify the BAM file for a reference sample, and we use NA12878 here. It is already specified, so let's make sure does have the file here. It does. Okay, so everything is good. You can obtain the corresponding BAM or CRAN files, depending on your genome build, 19 or 38, from the EBI website. One thing that I would like to mention is that for CRAN files, you may need to convert it to BAM or set the ref path and ref cache environmental variables. The one thing that you need to make sure is that if you use the SAMtools view command, you need to see the reads being printed. If you don't see this, particularly for CRAN files, you will need to either convert to BAM or set up these two environmental variables. And once we're done with this reference BAM file, we have completed the setup for the SCIP filtration and prioritization modules. We can now move to supplementary text 1 to run the pipeline. And these setup steps are only required once. So we're done with this, and let's move back to supplementary text 1. When using SCIP for the first time, you will need to follow supplementary text 2, which we just did. And the prerequisites here is the same as in supplementary text 2, and we already satisfied all of them. Actually reminds me that I need to load the R module. Every prerequisite is fulfilled. Then the next thing is to prepare the input files. The input file, for each given sample, you will need to prepare a tab delimited file called name.unfiltered_cmv.txt. This is the file that contains all the CMVs. And we already have that for this HSC033. So let's take a look at this. This is basically the format of this file. It is very simple. Chromosome, start, end, variation type. This and this can be free text, basically anything. And then the last column is the sample ID, HSC033001. Details about sample ID is explained here. To allow SCIP to recognize members of the same family, we utilize this naming structure. This can be your project name, this can be your family ID, and this can be the sample ID within your family. HSC033 is the name of the family, and 001 denotes the proband. As you can see, ABC123 is the family ID that should be the same for all family members. So SCIP basically used this to detect members of the same family. We need to place this file in the user data folder. Let's do that now using the mv command. User data. Okay, it's done. Moving on to the next step, basically modify the pipeline configuration file again. You may ask, we are talking about HSC033 here, but the alignment file name is actually called sample033001. How does SCIP know this sample and this sample are the same sample? That's why we need to do this step 2. Step 2 is essentially edit the sample ID entry within the configuration file. It is right at the top. So it basically needs to tell SCIP that sample 033001 is the same as HSC 033001. So you just make a file like this. This is your alignment name. This is your sample ID, and you make a file like this, and you specify it in the configuration file here. We are done with step 2 and moving on to step 3. Step 3 is to basically specify a cohort CMV file. SCIP has the capability to highlight CMVs from other members of the same family. And in order to do that, you need to include CMVs detected in other members of this family in the cohort CMV file and following this format. For our demo today, we're not going to do this. As you can see, this file is optional. We're just going to specify it to an empty file using the touch command. But if you want to study familial segregation, you must include this file. We're done with setting up and preparing the files, and the only remaining step is to run the pipeline. And running the pipeline is also very simple. So it is just one script. So it is this script, SCIP backend hg19.pl -n and specify the sample ID. And press enter, and it will be running. While it is running, let me explain to you how to know whether the execution of the program has succeeded. Expected output is first like this. For the filtration module, it will tell you filtration module script 1 is processing chromosome 1, so on and so forth. Now script 2 and script 3. These are the filtration module scripts. And then when moving on to the prioritization module scripts, it will display the date and time and the CNV being analyzed, as explained here. For filtration module, it would say this, like SCIP filtration module script 01, 02, or 03, processing HT19 chromosome 1, 2, 3, etc. For the prioritization module, it would display the current date and time, name of the CNV being analyzed, and whether it generates new or reuses SAM and DEPS files. You can see it here. So it will tell you that it is generating new temporary SAM and DEPS files. The only warning you may expect to see during this process are from SAM tools or TabX. For example, it may tell you that the index file is older than the data file, which is exactly the warning we're seeing here. This is the only warning that's expected running this pipeline. That is the index file older or protocol not supported or fail to open the reference. These are the only expected warnings, and no other errors are anticipated. As you can see, it is running the filter CNVs one by one. This is the last step of the backend. Once this script completes running, you have all the files necessary for visualization interface. I'm going to stop this video here and start another video once everything here has completed running, which will probably just take 2 to 3 minutes. I will start another video and continue on from this point and to show you how to set up and use the visualization interface. Thank you so much for your attention, and please feel free to let us know if you have any questions. Thank you again.